Good evening, children.
Good evening, ma'am.
Ma'am.
Good evening.
Ma'am.
Good evening, Prajit.
Good evening, ma'am.
Good evening,
Good evening.
Yes, ma'am.
Children, we have a new student in our classroom. So we are not continuing with, what we are supposed to. I'm just switching to a new topic in the same chapter. I'm just switching to a new topic in the same chapter so that even Prajit can follow today's session. And later, he will get to see the recordings and he'll catch up with the class. All right, Prajit?
Yes, ma'am.
All right. Yes, class. Videos on quickly.
Good evening.
I
didn't complete my homework, ma'am.
Yeah, no problem. We are not discussing today.
Okay.
I told you, no, we have a new student in our classroom, so we're not discussing the answers to the homework today. We are switching to a new topic.
Okay, ma'am.
Good evening, ma'am.
Good evening. Good evening, Danya. Yeah. So going down to, standard 7, standard 8. Okay, so Prajit, this is the first chapter in the NCERT maths textbook, number systems.
Yes, ma'am.
All right. So we have just started. I think we have about 20% past the chapter.
I have already seen the video.
Yeah. All right, class. So we have come across, in algebra, this phrase called like terms, unlike terms, like terms, unlike terms. Yes or no? Yes or no, children?
Yes, ma'am.
Yeah. Now tell me, what is 2x squared minus 5x cubed? What is the result? What is 2x squared minus 5x cubed?
Ma'am, 3x power 5.
Yeah, who's that?
Ma'am, Udan Shri.
Udan Shri. What's the answer?
Ma'am, 3x power 5, ma'am.
Anybody else wants to share the answer for this? Is it the same answer, 3x to the power 5? Or you have? Yeah.
Ma'am, we have to.
Cannot be added or not subtracted, ma'am.
Yeah, because they're unlike terms.
Yes, ma'am.
They are unlike terms.
Ma'am, in one multiplication, the addition of power takes place, ma'am.
Correct. This term, this is an x squared term, this is an x cubed term. They are not like terms. Like if you had 2x squared minus 5x squared, 2x squared minus 5x squared, then the result is minus 3x squared. X squared is written as it is, x squared as it is. 2 minus 5 is minus 3. 2 minus 5, we simplify the numerical coefficients. 2 minus 5 is minus 3 and x squared as it is. So here we call this the literal factor. The literal factor, literal is of letters, literal, meaning made up of letters. Like we say numerical, no, if it's made of numbers, numerical if it's made of numbers. Okay, we say numerical if it is made of numbers. We say literal if it's made of letters. Okay, so the literal factor is different. Here it is x squared, here it's x cubed. So in the two terms, the literal factors are different. So they're called unlike terms. So you cannot add or subtract them. Unlike terms cannot be added or subtracted. That expression. So what is the result then? The same thing. 2x squared minus 5x cubed. The same thing is the result. So 4x squared minus 5x squared plus 10x squared. All like terms. All the three terms are like terms, all x square terms. So x square once, it's not x to the power 6. Write x square only once. And simplify the numerical coefficients. 4 minus 5 minus 1. Minus 1 plus 10 is 9. 9x square is the result. 9x square is the result. Let me take a new slide. 1 second. Yeah. Now what is 4x square minus 5x square? Into minus 10x square. Can we multiply them?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
10x square.
X power 6, ma'am.
Multiplication can be performed on like terms as well as unlike terms. Addition and subtraction is sensitive. Addition, subtraction, sensitive. The terms have to be like terms. But
Square x square.
Yeah, but multiplication and division can be performed on like terms as well as unlike terms. I repeat, addition, subtraction can be performed only with like terms. Multiplication and division can be performed on both like as well as unlike terms. So multiplication and division is not sensitive in the sense you don't have to check if the terms are like terms or unlike terms. Whatever they are, you can multiply or divide. But if you have to add or subtract, you need to check if they are like terms. So this multiplication, you don't have to check whether they're like or unlike. It's multiplication. So multiply the numbers, multiply the numerals. Okay, so 4 5s are 20. 20 into minus 10 is minus 200. Multiply the numerals, multiply the literals. Multiply the literals. So when you multiply the literals, bases are same. So it's like x square into x square into x square. So you need to add the powers. When bases are same and it's multiplication, we add the powers. We add the powers, not multiply the powers, we add the powers. So this is the result. Minus 200 x to the power 6. When it's multiplication, multiply the numerals, multiply the literals. 4 5s are 20. 20 into minus 10 is minus 200. X square into x square into x square. Bases are same. Using the law of exponents, when bases are same and it's multiplication, we add the powers. So we add the powers like this. And the final result is minus 200 x to the power 6. What is 3x to the power 4 y square into minus 10 by 3 x to the power minus 2 y z cube. What's the result? Are they like terms?
No, ma'am.
They're not. And are we bothered if they're like or unlike?
No, ma'am.
No,
We are
ma'am.
not bothered because the mathematical operation is multiplication. Okay, since it's multiplication, we're not concerned. Let me say, I shouldn't say we are not bothered. We are not concerned. Okay, we are not concerned if the terms are like terms or unlike terms. We are not concerned because the mathematical operation is multiplication, and that can be performed with like as well as unlike terms. So how do we multiply? We multiply the numerals. So we multiply the numerals. 3 into minus 10 by 3. And we multiply the literals. So it will be x to the power 4 y. Then this x, I can write these two together, right? Y square and y z cube. Oh, y is there. Y and z cube. See, when you don't write, okay, you can put a multiplication sign if you're confused. You can put a multiplication sign. 3 and 3 gets cancelled. So we have minus 10. See here, x to the power 4 into x to the power minus 2. Y square into y. Y square into y. and z to the power 3. So what's the result? What is x to the power 4 into x to the power minus 2?
Ma'am, X square.
X to the power 2, ma'am.
X square. Then y square into y.
Y to the power
Y to the power
Y
3,
cube.
ma'am.
Yeah, and z cube.
Z cube.
All right, I think this is enough for you to recall that addition, subtract. So again, division also, if you want to take an example on division. So 35 x square y z to the power 4 divided by, say, 14 a b, whatever, z to the power 5. What's the result? Clearly, they're unlike terms. Clearly, they're unlike terms. So 7 5s are, but still you can divide. They are unlike terms, but you can divide. So 7 5s are, 7 2s are. So you get 5 by 2. Then AB as it is, that cannot be simplified. X square y also as it is. And you will have a z in the denominator. You will have a z in the denominator. That's all. This is the result. This cannot be simplified any further.
Yes.
All right. Now, coming to irrational numbers. Irrational numbers. All right. So expressions like √2, √3, √5, these we know have a non-terminating, non-repeating decimal expansion. These are called surds. Like we say like terms, we say like surds and unlike surds here. Like in algebra, we have, okay, so we say they're like terms, or we say they're like terms. Now if this, see, in algebra 2a and 3a are called like terms. Here, if I take away the a, if I take away a and replace it with √5, then these are called like surds. Like surds. They're irrational because the value of √5 is a non-terminating, non-repeating decimal. And when listen to this carefully, √5, the value of √5 is non-terminating, non-repeating. When you what is 2√5? 2 into √5. 2√5 meaning 2 multiplied by √5. So 2√5 also will be a non-terminating, non-repeating decimal. See, √5 has a non-terminating, non-repeating decimal expansion. And when you multiply that by 2, when you multiply that non-terminating, non-repeating decimal with 2, the result also, whatever is the result, that result will also be non-terminating, non-repeating. So clearly 2√5 is irrational. 2√5 is irrational because √5 is irrational. And when you multiply that by 2, the answer will again be a non-terminating, non-repeating decimal. So 2√5 is also irrational. Similarly, 3√5 is also irrational. √5 has a non-terminating, non-repeating decimal expansion. That value into 3 will be a different non-terminating, non-repeating decimal. So when they're non-terminating, non-repeating decimals, they are irrational numbers. And such expressions are called surds. And they're called 2√5 and 3√5 are called like surds because this factor √5 is the same in both. So when we say 2x plus 3x is 5x, or we say 2√3 plus 3√3 is 5√3. Simply look at that as x. What will be your answer? What is 2x plus 3x? 5x. So 2√3 plus 3√3 is 5√3. If you want the steps, it's like this. If you want to y like that. So what is common? √3 is common. √3 is common. So 2 plus 3 in the bracket. Root 3 is common. 2 plus 3. So it's 5 root 3. So it's 5 root 3. Exactly the way we handle, like terms and unlike terms in algebra. It's the same way we are going to handle like surds and unlike surds. Like surds and unlike surds in, number systems. Something understood, children?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So now root 7, Prajit, it might be new to you, but I hope you can somewhat understand what I'm trying to say.
Yes, ma'am.
Did you go through the meeting recordings?
Yes, ma'am. I did, ma'am.
Okay. All right. Now, what is 3 root 7 minus 4 root 7? How do you handle this? What is common?
To the
Minus 1 root 7.
Correct.
7,
What is
ma'am.
common? So if you want the steps, root 7 is common. 3 minus 4. 3 root 7 minus 4 root 7. So it's minus root 7. Minus 1 root 7 or simply minus root 7. Like minus 1x is simply minus x. Minus 1x is nothing but minus x. When the numerical coefficient is 1, you can just ignore it also. It's understood it is 1. Similarly, here you can simply ignore this. 1 root 7 is nothing but root 7. Minus cannot be ignored. Minus root 7. Just like algebra, just treat this as y. What is 3y minus 4y minus y? Minus root 7. That's all. No, understand this clearly, children, because I'm going to give you a test straight away.
Yes, ma'am.
Straight away, I'm going to give you a test.
Yes,
So
ma'am.
understand this carefully. Now, what is the answer for this? Are they like surds or unlike surds?
Unlike.
Unlike
surds,
Unlike surds. They are unlike surds. Can you multiply them?
Yes, ma'am.
Yeah,
Yes,
you
ma'am.
can because when the operation is multiplication, it can be anything. They can be like or unlike surds. You can multiply them. You can multiply. And how do you multiply? Like you multiply the numerals there. Here also you multiply the rational factors. These are the rational factors. These are the irrational factors. These are the rational factors. These are the rational factors. Rational factors. And these are the irrational factors. Irrational factors. Excuse me, children. Yeah. So these are the rational factors. These are the irrational factors. Multiply the rational factors. 3 2s are 6. Multiply the irrational factors. Root 7 into root 3. Root 7 into root 3.
Root 21.
6. Yeah, root of 7 into 3. Root of 7 into 3. Because both are under the square root. See, if it was square root of 7 and cube root of 3, you cannot multiply these two. Because these are called, I'll come to this later. I think I shouldn't give you this example now and confuse you. The third factor itself is different. We'll take up this. This is not there for the test, which I'm going to give you now. So let me not talk about it now. So here the third factor is the same root. This is also square root of 7. This is square root of 3. So it will be the square root of 7 into 3. Square root of 7 into 3. 6 root 7 into root, I told you 3 into 2 is 6. Then root 7 into root 3. Root 7 into root 3. How do you do that? It will be 6 root of 7 into 3. That is 6 root 21. So these are called surds of different order. Since I mentioned, then you might be like, why is she not saying about that? So these are surds of different order. Cube root, fourth root. These are surds of different order. Surds of different order. So how to multiply these, we are not learning now. We will be learning, but not now. Okay, we are not going into this now. So this you will see later in the chapter. These are called surds. All these are surds of different order. The order here is 2. The order here is 3. The order here is 4. The order here is 5. Like we say square root, cube root, fourth root, fifth root, sixth root, seventh root, and so on. They are all surds, but of different order. So in order to multiply them, you need to make them of the same order and then multiply. So we'll see that later. So simple examples. Let's finish this fast. What's the answer for this? What's the answer? Just tell me the final answer.
6.
6 to the root
5. 6 root 5.
6 root 5, ma'am.
6 root 5. What is 10 root 3 minus root 3?
ma'am. 9 to the root
9
3.
root 3.
9 root 3. See, 9 into root 3. 9 root 3. 9 root 3. What is root 5 into 3 root 2?
Ma'am, 3 root 10.
3 root 10.
3 root 10.
3 root
10, ma'am.
Yeah. What is root 21 divided by root 7?
Root
Ma'am, root 3.
3.
Ma'am, root 3.
That's great.
3, ma'am.
See, you can handle this in 2 ways. You can write it as root of 21 by 7. Root of 21 by 7. So 7 ones are 7 threes are. So root 3. You can handle it like this, or you can write the numerator as root 7 into root 3. Okay. Root 21 is root 7 into root 3 by root 7. So they get cancelled and root 3. Anyways. Because both are under the square root, you can say square root of, excuse me, children. Yeah, so it can be a root of root of 21 by 7. 7 ones are 7 threes are, which is root 3. You can handle it like this, or you can split root 21 as root 7 into root 3 by root 7. Root 7 cancels and the answer is root 3.
Yes, ma'am.
Yes, ma'am.
Videos on, all of you. See, you don't know, when I'll just remove children whose videos are not on during the meeting. You don't know, and you cannot blame me because this is the standing instruction. You have some standing instructions for this class.
Excuse me, ma'am.
Yes, Madhumita.
Ma'am, I'm attending class from a different PC today, ma'am, and I don't have a camera on this PC, so I won't be able to turn on my video this class, ma'am.
Okay, so excuses like this, kindly text me so that I don't disturb you during the session.
Yes, ma'am.
If you've already texted, you can ignore whatever I say during the session. Yeah, so every other class children cannot give me this excuse.
Yes, ma'am. That PC is not working properly, so
Yeah.
I'm attending from a different PC.
Yeah, okay. Are we ready with this, children? Are we ready for the test now?
Yes,
Yes,
ma'am.
ma'am.
Okay. All right. Okay. Let me just tell you this also. Just one more. Just one more. What is 4 cube root of 7 minus 2 cube root of 7? Are they like surds?
Yes, ma'am.
So
Yes,
these are
ma'am.
surds of third order. Third order. These are surds of third order. Cube root of 7. So here also, see this cube root of 7, cube root of 7. So they are like surds. They are like surds. What's the result? What is common? Cube root of 7 is common. So you will have 4 minus 2. In the bracket, 4 minus 2. So it's 2 cube root of 7. Don't forget to write this cube root. Is this correct?
Yes, ma'am.
Yes, ma'am.
Okay, so I think we are good to go now. Yes. Finish the first, I think I have all the answers on the same slide. So you have to finish everything. Since I have all the answers on the same slide, take down the question and then answer it. See, you can straight away write 4 root 11, or if you want, see, I'm just helping you with the first one. You can straight away write the answer 4 root 11. Or if you want to, you can show this step. You can open a bracket. There's 1 here, no, there's 1. So 1 plus 3 root 11, because root 11 is common. Root 11 is common. So in the bracket, you would have 1 plus 3. 1 plus 3. So 4 root 11. So it's optional. You want to show the step, fine. Otherwise, you can give the final answer straight away. Okay, children, we'll see the answers to the first 5 questions. First 5 questions. The first one I already told you, so I'm not asking anybody. It's 4 root 11. Yeah, Raja, what's the answer for the second one? Raja?
Ma'am?
What is the answer for the second one?
Ma'am, root 7 plus 2 by 2 root 5.
Root 7, huh? What is 2x minus 3x?
Ma'am?
What is 2x minus 3x?
Ma'am, 1x, ma'am.
Then what is 3x minus 2x?
Ma'am,
No, if 3x, if 2x minus 3x is x.
sorry,
Okay,
ma'am.
we get different answers when you subtract. No, 5 minus 4 is 1, but 4 minus 5 is minus 1. You are saying 5 minus 4 is 1, 4 minus 5 is also 1. Yes, Raja, wake up. Raja, what is 2 root? What is 2x minus 3x? Simple. What is 2 minus 3?
Minus x.
Minus x. So it will be minus.
Minus root 7.
Yeah, minus root 7. Good. Minus root 7. Then?
Minus root 7 plus 2 root 5.
Yeah, minus root 7 plus 2 root 5. Because only these two are like surds. Only these two are like surds. Class must listen. Don't go ahead. Only these two are like surds. They're of the same order. 2. They're of the same order. 2. 2 is the order of the surds. Okay, so only these can be simplified. Like 2x minus 3x is minus x. Here it is minus root 7. And this one as it is. So that's the answer for the second one. Shri Krishmi, are you there? Shri Krishmi. No answer. Netra, what's the answer for the third one?
12 root 225.
12?
12 root 225.
12 root 225. Okay. All right. So let me say something. For the third one, children, 2 root 7, 3 root 7, 2 root 5. Okay.
2,
Tell
4,
me
5.
third question. Tell me the third question again, children. What's the third
2
one?
into 3 root
Ma'am,
7 into
root
5.
7
Into
2
2
to
root 5.
root
5, ma'am.
2 root 5. 2 root
Ma'am,
5.
I actually got a different answer. Can I share it?
Yeah, what's your answer, Madhumita?
Ma'am, I got 12 root 35.
12 root 35.
Yes, ma'am.
Answer.
Okay. Just check if all of you have done like this. All of you have to pause. Don't go ahead. Stop and listen to this. Is this correct? Is this what I told you? Did I say this one?
No, ma'am.
Oh, I didn't explain like this. Come on, children. How do you multiply root
No,
7,
ma'am.
root 7, and root 7?
Ma'am, I should commonly take 7 and multiply it with root 5.
Okay, fine. All right, 1 minute.
Oh, I did like this one.
Now, root 21, we break it as root 7 into root 3, right?
Yes, ma'am.
How did we, how is root 7? Didn't we multiply root 7 and root 3? How do we multiply root of 7 into 3? Root 21, yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so that's what I wrote now. 2 into 3 into 2. I'm multiplying the rational factors. I'm multiplying the rational factors. Then I have to multiply the irrational factors of the same order. This one, correct? I can put a multiplication sign or I can simply put a square root.
Yes,
I
ma'am.
can put a multiplication sign or no. It's okay. So what all should I multiply? I should multiply 7
7.
under square root 5. Okay, I can give you one more step. If you want, I can give you one more step. See here. It's 2 into 3 into 2 into root 7 into root 7 into root 5, which is 2 3s are 6, 6 2s are 12. Root of 7 into 7 into 5. Now what will be the next step? Tell me.
12.
8
And
standard.
12,
Root
5.
225.
2 for 5. 2 for 5.
No.
45, ma'am.
12 root 225, ma'am.
Think of something
12
else,
to 2.
children. Think of something else. Go down to 8 standard.
And 49 into 5.
No. You should not multiply 7 and 7. Why? Squares and square roots. 8 standard.
7
Ma'am,
square.
take 1 7 as common,
Yes.
ma'am.
Yes. Danya, you are right. Come again.
Ma'am, we should
Danya?
take 1 7 common, ma'am.
No. From 2 sevens, 1 7 will come out of the square root, right?
Yes, ma'am.
From two sevens, which are under the square root, from 2 equal factors, 1 will come out of the square root. This is of squares and square roots, 8th standard. Don't you remember simplifying? If you have 5 into 5 into 2 into 2, what will you do? The answer is from 2 5s, 1 5 out of the square root. From 2 2s, 1 2 out. 5 2s are 10 is the answer. If it was cube root, you should have another 5 and another 2. From 3 5s, 1 5 will come out. If it's under the cube root, from 3 2s, 1 2 will come out. 5 2s are 10. Children, you cannot say that you didn't come across this in squares and square roots in 8th standard. This is how we used to find the square root of a perfect square using the prime factorization method. Using prime factorization method, this is what we used to do. From 2 equal factors, we used to bring 1 out of the square root. So from 2 sevens, because it is under the square root, from 2 sevens, 1 will come out. Yes or no? Now say yes or no.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Then what remains under the square root?
5, ma'am.
5.
So what should I write now?
Ma'am, 84
Root
root
5.
5.
See, if I'm into 12 sevens are 84. 84 root 5 is the answer. 84 root 5 is the answer. Let's do it again. Don't panic. See, supposing you had you had to find the value of x last year. Supposing you had 9 into some 49 into 25. X is equal to, you should not multiply all these numbers. When you have some numbers under the square root, you're not supposed to multiply all these numbers. You must break down the numbers into a product of their prime factors. So 9 should be written as 3. 49 should be 7 into 7. 25 should be written as 5 into 5. Now what happens? Equal to, from 2 3s, 1 3 out. From 2 7s, 1 7 out. Out of the square root. Out meaning out of the square root. And from 2 5s, 1 5 out. So x is equal to 3 7 are 21 into 5 105. See, we got the answer so quickly. Imagine you multiply these three numbers, you get a bigger number, and then you have to find the square root of that big number. It's time consuming. You will get the same answer, but it's time consuming. And this is how you're expected to do. When you have some numbers under the square root, you will have to break down the numbers. Write them as a product of their prime factors. 9 as 3 into 3, 49 as 7 into 7, 25 as 5 into 5. Now from 2 equal factors, 1 will come out. 2 3s, 1 3 out. Because square root, if it was cube root, then from 3 3s, 1 3 will come out. From 3 7s, 1 7 will come out. Supposing you have only 2 7s under the cube root, nothing will come out. Under the cube root, if you have 2 7s, nothing will come out. Because you need minimum 3, or then you need 6 or 9. Now tell me what is root 7 into root 7 into root 5 into root 5? Can I put everything under the same square root? And
Yes, ma'am.
multiply?
Yes, ma'am. It's
Yes,
root
ma'am.
35.
35.
35, ma'am.
35.
It's all square
30.
root.
Ma'am.
Correct. But so it will be root of 7 into 7 into 5 into 5, correct? Again,
Yes,
children,
Yes,
root
It's
A
only
into
35.
B is root AB. This is all of squares and square roots. I don't mind. See, if you tell me if you don't understand, I can repeat it for you. I'm saying you that it's not a 9th standard. Root A into root B is root of AB. It's all 8th standard. You just understand this. Don't worry. You don't have to write all that. So now all under the square root, all under square root. So you can put one big square root like this and write 7 into 5 into 5. Now you should not multiply. You should not multiply. That is not what we have learned from the chapter squares and square roots. You should not multiply. From two equal factors, one comes out of the square root. From two equal factors, one comes out of the square root. So 7 5s are 35 is the answer. Now
Yes,
tell
ma'am.
me what is root 7 plus root 7 plus root 5 plus root 5. What's the answer for this one? Think.
Ma'am, 2 to root 7 plus 2 to root 5, ma'am.
2 root 7 plus 2 root 5.
Yeah, others share your answers. It can be the same answer or a different answer. You can still say yes.
24.
No, it is not square root of 24.
Ma'am, 2 root 7 plus 2 root 5, ma'am.
Addition and subtraction can be performed only on like surds. So these two are like surds. These two are like surds. So we can perform addition or subtraction only on like surds. So now this is 1 root 7 and this is 1 root 7. So 1 plus 1 root 7 or 2 root 7. 2 root 7. 1 root 7, like 1x plus 1x is 2x. 1 plus 1 root 7 plus 1 plus 1 root 5. Root 5 is common. 1 plus 1. So like similar to this, what is x plus x 2x? Because it's 1x plus 1x 2x. Similarly, 1 root 7 plus 1 root 7 is 2 root 7. 1 root 5 plus 1 root 5 is 2 root 5.
Yes, ma'am.
Just related to algebra, like surds, like terms. I said root 7 plus root 7 plus root 5 plus root 5. Nothing to get confused. It's addition. Addition can be performed only with like surds. These two are like surds. These two are like surds. So you have to handle them separately. Okay, so let's do this one. Root 7 plus root 7. You should not, this root 7 I told you will come out as it is root 7. So it's 1 plus 1. 1 root 7 is common. So it will be 2 root 7. Similarly, it will be plus 2 root 5. So the answer is 2 root 7 plus 2 root 5. So that's the difference. That's the difference. Let's do now everything. Meaning we'll do all this. One is Root 7 plus root 7 plus root 5 plus root 5. What's the difference? Root 7 into root 7 into root 5 into root 5. What's the difference? Here it's addition, only like sets, only like sets. Here it's multiplication, everybody can be done. Of the same order. They must be of the same order. So here it will be root 7 plus root 7 is 2 root 7 plus root 5 plus root 5 is 2 root 5. But here you should write as root of 7 into 7 into 5 into 5. You can multiply all of them, you can multiply. So put them all under the same square root. Now from 2 7s, 1 7 out. From 2 5s, 1 5 out. The answer is 35.
Ma'am, your screen is lagging.
Children, you're not able to see my screen?
It's you will be able to see. Able to see.
Ma'am,
Yeah,
I'll
class,
try
tell
leaving
me.
the meeting.
My
ma'am.
screen is clear.
Yes, ma'am. Your screen is clear, ma'am.
Yes, ma'am.
Yes, ma'am. Yes.
Maybe you can leave the meeting and join again. No, I'm pausing so that you process it in your mind. I'm just giving you time to process the concept in your mind. Okay. Now tell me, what is root 11 into root 11? How do you handle this? How do you handle root 11 into root 11?
Root 121.
Root 121.
Root 121. Ma'am, it's root 11.
Ma'am, it's root 11, ma'am. Ma'am, it's root
No, I'm
11.
waiting for the correct answer.
Ma'am, it's root 11.
Ma'am, it's 11, ma'am.
Yeah, who's that? Who's at 11?
Ma'am, Sindhu, ma'am.
Sindhu. Yes, Sindhu. How do you work? I mean, how do you work that answer? How do you work root 11? Tell me the steps.
Ma'am, under root 11 into 11, ma'am. And from that pair, we should take
Sindhu, show yourself on the screen. Yes, Sun. Just turn the camera to Sindhu. Where is she? Only Sunday shows up in the video. Where are you, Sindhu? Yeah, Sindhu. Yes. You can take turns, no? Once your brother can sit, then you take turns. I always see Sanjay. Yes, Sindhu, tell me the steps.
Ma'am, she is in mute.
Ma'am, can you hear me, ma'am?
Yeah. Yes, now I.
Ma'am, under root, you have to put 11 into 11.
Yes. Very good. Then.
And from that pair, we should take 1 out, ma'am. So the answer
One
is
2
7.
11s. 1 11 comes out. Square.
Yes, ma'am.
So the answer is 11.
Yes, ma'am.
Two root 11.
What is root 11 class?
2 root 11.
2 root 11. Yes.
2 root 11.
11.
Now,
2 root
2
11.
root. Yeah, because it's 1. Yeah, because it's 1 root 11 plus 1 root 11. So it's like root 11 is common. 1 plus 1. See at 1 root 11, don't we take out common? Like that's what we do for 2x plus 3x also. X is common. X is common, 2 plus 3. So 5x. Let's repeat this till all of us understand. What is root 13 into root 13? And what is root 13 plus root 13 plus root 13?
Ma'am, root 13 into root 13 is 13.
What is root 13 into root 13?
Ma'am, root 13 into root 13
Tell
is
me the
13.
root of
13 into 13.
13.
And 113 comes out.
13 comes out and 13 is the answer.
correct?
13, ma'am. Yes, ma'am.
But here 1 root 13, 1 root 13, 1 root 13, they're all like surds of the same order. So it will be 1 plus 1 plus 1 in 13. So what?
Ma'am, 3 to the root 13.
No, we'll not say 3 to the root 13. That is to the power of. See, we are used to that because we say 2 to the power 5. No, it's not like that. It's simply 3 into root 13 or 3 root 13. What do we understand by 3 root 13? It is 3 into root 13. 3 times root 13. 3 root 13 means 3 times root 13. Like what is 5 into 4? 5 times 4. 3 root 13 is a product. 3 into root 13. It's a product. 3 times root 13. 3 root 13. There is no sign here like 5x. What is 5x? 5 into x. 5 into x. What is 5x? 5 into x. What is 3 root 13? 3 into root 13. What is root 13? It's a non-terminating, non-repeat. It has a non-terminating, non-repeating decimal. Into root 3, which is rational, will also be a terminating. So 3 root allow you to go wrong and be demotivated. Shall I show you the answer slide also? Or now it's more clear? Can you proceed on your own?
Yes, ma'am.
Ma'am, it's clear, ma'am.
Will you proceed?
Yes, ma'am.
Okay, fine. Let's. Yeah. Fine, children. Now try this. Yeah, I think we have to still discuss 4 and 5. So let's come back to our earlier discussion. So 2 root 7 to I was telling you about this 2 root 7. I explained this one. 2 root 7, 3 root 7. The answer for this 3 root 7 into 2 root 5 is 2 into 3, 6, 6 2s are 12. Root of 7 into 7 into 5. So it's 12 into from 2 sevens, 1 7 out. 5 remains under the square root. 5 remains under the square root. 84 root 5. These are the steps for the third one.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. Continue. Yeah, what's the answer for the fourth one? I again forgot that we were discussing.
Ma'am, 14 root 3, ma'am.
14 root 3. Okay, so it's all root 3, root 3, root 3, root 3, root 3, root 3. And it's all addition, subtraction. Everywhere it's addition or subtraction. So we need to check if they're like surds. Whenever we have to add or subtract, check if they're like surds. Yes, they're all like surds. So now simplify their coefficient, the rational factors. 3 plus 4, 7. 7 plus 11, 18. 18 minus 6, 12. 12 minus 1, 11. Yes, somebody told the right answer. 11 root 3.
11 root
Yes.
3. It's 11.
11. Yes, yes. Right. Class C again. 3 plus 4. See, all these are like surds. All of them are like surds. So you can simplify. You can add and subtract them. 3 plus 4, 7. 7 plus 11, 18. 18 minus 6, 12. 12 minus 1, 11. Root 3. When you have 5x plus x plus 2x plus 3x, what's the answer? 5x, 6x, 7x, 8x, and 11x. X will come only once. And the answer for this one, the fifth one? What's the answer for the fifth one?
Root 10, ma'am.
21 root 10, ma'am. 21 root 10.
21 root 10.
This one is 10 root 2 into 3 root 5. So it is 30.
Ma'am,
It's 20.
7, ma'am.
I'm 21 root 10, ma'am.
7, ma'am.
7, ma'am, because it's
5 plus 2 is 7,
7,
ma'am.
sorry.
it's addition.
Oh my God, sorry. 5 plus 2, 7, 7 root 2. I'm sorry, children. Into 3 root 5. So it's
Yes, ma'am.
21 root 10. Correct?
Yes, ma'am.
Yes, ma'am.
All right. I'll not disturb you. Yeah, continue. Finish all the 15, children. I'll not disturb you. Finish all the 15.
Finished, ma'am.
Completed, ma'am.
Completed.
Complete.
Finished.
Yes, ma'am.
Yes, ma'am.
Very good. I'll just wait for 2 more minutes, just in case some of them have to still do. Disable your mic, all of you.
Completed, ma'am.
Okay. Let me show you the answer slide. Should I wait for anybody? Okay. Yes, check your answers, children. Go through each and every answer, please. Disable your mic. Somebody's mic is enabled. Disable your mic.
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt in the 9th one.
Yes, Madhumita.
Ma'am, aren't we supposed to subtract root
Yes,
5 and root 6? Like 5 minus 6, so 3 by 5 minus 3 by 5 minus 1 root.
Question number
9, ma'am.
9. In question number 9. Yeah. 3 root 5 by 5 root 6. Yeah, what can be done further? Tell me.
Ma'am, like can we subtract both the roots like 5 minus 6 and write root minus 1?
No. You are saying you can root 6 is not equal to root. You are saying root 5 plus root 1 or something like that.
No, ma'am. I said we can subtract both the roots, like root 5 minus root 6.
It's division, no?
Yes, ma'am. But
You can add.
there's that property, no, ma'am. A
Five.
power m divided by a power n is a power m minus n.
But where are you seeing? Where are you seeing a to the power? Which is the common base here?
Yes, ma'am. Now I understand.
No, you're right. A power m divided by a power n is a to the power m minus n. That's right.
Yes, ma'am. But there's no common base here.
Yeah, this is the base upon. So 6 3s are 6 5s are 3 by 5. 3 root 5 by 5 root 6. What you can further do is you can write 3 by 5 and root of 5 by 6. But you cannot still cancel anything.
Okay, ma'am.
You cannot cancel anything. So that's it. 3 root 5 by 5 root 6.
Yes, ma'am.
So here root 7 and root 7 gets cancelled. 16 by 2 is half. Again, when it's multiplication, this 2 is out here. Root 2 into root 5 is root of 2 into 3 into 5. And we don't have pairs of equal factors, so you have to multiply. 2 3s are 6, 6 5 are 30, because nothing will come out of the square root.
Yes, ma'am. I got that one right.
Yeah. No, I'm just telling the whole class. Yeah. In question number 12, it's multiplication, children. It's not addition, it's multiplication. So it's root of 3 into 3 into 3 into 3. From 2 3s, 1 3 out. From the other 2 3s, 1 3 out. From 2 3s, 1 3 out. From these two 3s, 1 3 out. So 3 3s are 9.
Ma'am, I got all the sums right other than the 9th one, ma'am. And now I understand the 9th one.
All right, Madhumita, yeah. See the 13th one, children. Cube root of 5 into cube root of 5. Yes.
Ma'am, in the 13th and 14th, in 13th, my sorry, ma'am, in 12th and 13th, in 12th I got the answer as root of 81 and root of 81 is 9, ma'am. Is that also correct, ma'am?
Correct, but I don't want you to multiply. You're right. Even if we multiply everywhere, we will get the same answer, the correct answer. But the thing is, why do you want to multiply? Now the numbers are small, so we multiplied. What if it was like root of say 23 into root 23 into root 23 into root 23? Supposing it was like this. Now because it was 3, you got root 81 and 9 immediately. Now then you would have done root of, would have multiplied all these numbers 23, 23, 23, 23, and then you will get a big number and you get stuck there. Yes or no?
Yes, ma'am.
Yeah. So when the numbers are small, we have the convenience to do either ways, but we should not get used to that. We should not get used to multiplying. You should not multiply 3 3s are 9, 9 3s are 27, 27 3s are 81. You should not do that.
Yes,
It should occur to you that under the square root, when we have pairs of equal factors, we need to bring one. Please type out that and write it like this.
yes, ma'am.
Awesome. Good. You should not multiply. No, we'll get used to it. That's all. We'll get used to that. We'll not get used to that.
Yes, ma'am.
So here it is cube root of 5 into cube root of 5 into cube root of 5. So it's cube root of 5 into 5 into 5. Do we understand that? What is the order of the third here? What is the order of the third?
Ma'am,
What is the
ma'am, cube root of 5, ma'am.
No, you must say 3.
Yes, ma'am.
When it's cube root, you must say the order is 3. Order is 3.
Yes, ma'am.
What's the order here?
Ma'am, 7, ma'am.
What's the order here? 7. All right. So it will be cube root of 5 into 5 into 5. So from 3 5s, 1 5 out of the cube root.
Yes, ma'am. Ma'am, I understood, ma'am.
But look at this one. This is cube root of 5 plus cube root of 5 plus cube root of 5. Addition. When you're adding or subtracting, it is like this. You take out cube root of 5 common. So it will be, this is 1 cube root of 5, 1 cube root of 5, 1 cube root of 5. So like this, 3 cube root of 5.
Yes, ma'am.
Yeah. In the last one of the fourth order, we have so fourth root of 2, fourth root of 2, fourth root of 5, 7, fourth root of 5. Let's understand how to read them. Fourth root of 2. Class. See, most of your videos have gone off. Turn on your videos, all of you.
No, miss.
No, my video is off. On only.
Ma'am, my video is on, ma'am.
My video is also on.
Yes,
Ma'am,
ma'am,
my
me
video is
too,
also
ma'am.
on.
Ma'am, my video is also on.
Yes, ma'am. Fine.
Class, use the emoji, raise your hand. Use the raise hand option, raise your hand. Raja, Sanjay, Sindhu, Devadarshini, Rajit, Madhumita, Udanshri, Danya, Krishmika, Netra, and Jayant. Jayant, are you there? All right. All right, children, I'm talking about the last one. The last one, fourth root of 2 plus fourth root of 2 plus fourth root of 5 minus 7 into fourth root of 5. This is how you read it. Fourth root of 2, fourth root of 2, fourth root of 5, 7, fourth root of 5. So it's 7 into fourth root of 5. What is 7 fourth root of 5? 7. 7 we know the value of 7. We know 7 is 7. Into whatever is the value of fourth root of 5. It's a product of those two. 7 fourth root of 5. Fourth root of 5 is, what is the value of fourth root of 5? Some number multiplied by itself, some number multiplied by itself 4 times should give you 5. Like we say the cube root of 27 is 3. Why? Because 3 multiplied by itself 3 times will give us 27. Cube root of 27 is 3. Because 3 multiplied with itself 3 times will give us 27. Similarly, fourth root of 5 means some number multiplied by itself 4 times should give you 5. And we know there is no such number. So fourth root of 5, the value is a non-terminating, non-repeating decimal. The value of fourth root of 5. There is no number which when multiplied by itself 4 times can give us 5. 1 into 1 into 1 into 1 is 1. 2 is 16. 3 4 times is 81. There is no number which when multiplied by itself 4 times can give you 5. So the value of 4th root of 5 is a non-terminating, non-repeating decimal.
Yes, ma'am.
Yeah. So now coming back to this, see here, 1 plus 1 into 4th root of 2. 1 minus 7 into 4th root of 5. 1 minus 7 into 4th root of 5. Because you cannot simplify all of them at the same time. These two are like surds, these two are like surds. So you'll have to simplify them separately. So we get 2 4th root of 2 minus 6. See here, minus 6 4th root of 5. I suggest you practice the same thing once again.
Yes, ma'am.
At home. That should help.
Yes, ma'am.
Am I audible and clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Hello, children. So let me check again before proceeding. So class, tell me what is 10 root 11 minus 5 root 6 plus 2 root 11. What's the answer?
12 root 11
Root 6, ma'am.
minus
12 root 11 minus 6.
5.
This is right? Yes.
Yes, ma'am.
What is root 19 plus root 19 plus root 19?
3 root 19.
3
3
root
root
19.
19.
3 root 19.
Because everywhere it is 1, it will be 1 plus 1 plus 1, root 19, which is 3 root 19. What is cube root of 17 into cube root of 17 into cube root of 17 equal to?
17. 17.
Yeah. Tell me the steps, Project.
17 into 17 into 17 whole root under root into 7 is equal to 17.
Root of what root? Just root, square root?
Cube root, ma'am.
Cube root. What's a cube root of 17 into 17 into 17? So what happens?
17.
From 3 equal
17
factors,
comes out.
It comes out, ma'am.
1
17.
comes out. So the one, yeah, so the value is 17.
Yes, ma'am.
Yeah. All right. You may write it down. I'll give you some time. A plus B into A plus B is A plus B the whole square.
A plus B,
And A plus B the whole square is A square plus 2AB plus B square.
B square.
I don't want to read it out and disturb you. You all know this. You're very familiar with these. Write down your books.
Yes, ma'am.
Completed, ma'am.
Yeah.
Completed, ma'am.
All right.
Completed, ma'am.
Fine. Now we are going to solve
Last
the expressions. Yeah.
Ma'am, 1 minute last line, ma'am.
Yeah, sure, sure.
Is it a homework?
No, no, no. We are going to do it now.
Thank you.
Yeah.
Yes, thank you, ma'am. Thank you, ma'am.
Yeah. So children, we are going to solve these expressions using an appropriate identity. We're going to solve using an appropriate identity. I'll show the first one for you. Then the rest will be a test. I'll show you the first one. See the steps for the first one. You can help yourself. First you go through and then maybe I can explain it line by line. Please write on your books also. I'll explain it and then you can ask your doubts. Now write on your book. Yes, children. You should have finished by now. So it's 2 root 3 minus 5 into 2 root 3, 2 root 3 minus root 5 into 2 root 3 minus root 5. Should I wait? I don't want to talk when you're writing.
Yes, ma'am. I'll be done in 2 minutes.
Yeah.
Completed, ma'am.
Okay. I want all of you. Yeah, to acknowledge. Yeah.
Completed, ma'am.
All right, children.
Completed.
So please listen.
Completed.
Nice, children. Fine. All right, good. Please listen carefully. So it's like it's 2 root 3 minus root 5 into 2 root 3 minus root 5. So both the brackets have the same term. See at the first term 2 root 3, 2 root 3. Second term root 5, root 5. The separator is minus. So it's clearly of the form a minus b into a minus b, which is nothing but a minus b the whole square. The given expression is of the form a minus b into a minus b, which is a minus b the whole square. Now see here, just compare what is a? 2 root 3. For minus, we have a minus here. So b is only root 5. B is not minus root 5. Just compare. See here, a minus b, because sometimes we have a doubt if b is root 5 or minus root 5. See here, a goes with 2 root 3. Minus goes with the minus. B is root 5, that's all. It's like minus b is equal to minus root 5. Minus b is minus root 5. So b is only root 5. Also keep your videos turned on.
Yes, ma'am.
All right. So a is equal to 2 root 3. B is minus b is equal to, if at all you're getting confused, you know. So it's like a minus b. A is equal to 2 root 3. Minus b is equal to minus root 5. So minus gets cancelled. B is equal to root 5. B is only root 5. So you can see here, this is the first step. Then write the identity and write out the values of a and b. Write out the values of a and b. Now a minus b the whole square is a square. So this one, a square, this is a square. Then you can see plus identity, we know a square minus 2ab plus b square. So this is a square, this is b square plus b square, and this is minus 2ab. 2 into a into b. Just substitute the values. This is a square. This is b square. This is 2ab. Now, what is 2 root 3 the whole square? 2 root 3 the whole square means 2 root 3 into 2 root 3. Am I right?
Yes, ma'am.
Yes, ma'am.
2 root 3 the whole square means 2 root 3 into 2 root 3. Now you have learned how to find 2 root 3 into 2 root 3. What is 2 into 2?
4, ma'am.
You can see that here, 4. What is root 3 into root 3? Root of 3 into 3. Root of 3.
3, ma'am.
And that means from 2 3's 1 3 comes out of the square root. So it is 3. You don't have to show those steps. You can directly write what I've written here. So 2 squared is 4. Root 3 into, because 2 root 3 into 2 root 3. 2 into 2 is 4. Root 3 into root 3 is root of 3 into 3. And from 2 3's 1 3 out of the square root. So 3. Similarly, root 5 the whole square. Root 5 the whole square meaning root 5 into root 5. It's root of 5 into 5. So from 2 5's 1 5 out of the square root. You can see it here. Root 5 into root 5 is 5. Then 2 2's are 4. Root 3 into root 5 is root 15. Same thing. Root 3 into root 5 is root of 3 into 5. So which is root 15. So it's 12 minus 4 root 15 plus 5. 12 plus 5 is 17. 17 minus 4 root 5. 4 root 15, sorry. 12 plus 5, 17 minus 4 root 15. Is that fine, children?
Yes, ma'am.
All right. Try. Yeah, please do the second one. I'll give you about 3 to 5 minutes time. I didn't notice the time, children. I think it's time for today's class. I have a next meeting at 7:45. Class, I didn't look into my mobile phone. It's 7:35. I have a meeting at 7:45, children. So we need to wind up today's session. So was it clear, children? Whatever was discussed today?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. April 14th, our next class will be on the day after tomorrow. But since it's the Tamil New Year's Day, we will not be having class on that day. I think you can just take a screenshot of these answers and complete them. We'll discuss them in the next class on Saturday.
Okay.
Take a screenshot, children. Practice. This is the second answer. Okay, let me show you all the questions first. These are the questions. Take a screenshot. Answer, which you just completed. The second one.
Yes, ma'am.
This is the second one. Done, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yeah, third answer. This is the third answer. A plus B into A minus B is A square minus B square.
Taken, ma'am.
Taken, ma'am.
Yeah. Tell me the answer for this. What is ABC the whole square?
Ma'am, ABC into ABC.
ABC into ABC.
Yeah, what's the answer?
ABC and ABC.
What is ABC into ABC? ABC, ABC. No.
Square.
Square and B.
A square?
A square, B,
B
square, C
square
square,
and
ma'am.
Yeah. A square, B square, C square. It's not ABC, ABC. It is ABC, ABC, but it can be further simplified. A into A square. B into B, B square. C into C, C square. ABC the whole square. ABC the whole square is not ABC square. Remember that it's not ABC square. It's A square, B square, C square. Similarly, when you square this 4 root 5, the whole square, you should square 4. You must square 5 or this one also, root 5 also. That's what I'm trying to say. 4 root 5 the whole square means 4 root 5 into 4 root 5. 4 into 4, 16. You can see it here, 16. Root 5 into root 5 is 5. Okay. The fourth one. This is the fourth one.
Taken, ma'am.
All right. This is the fifth one.
Taken, ma'am.
All right,
Taken, ma'am.
all right, children. So that's it for today's session. Thank you so much. Let me leave the call.
Thank you, ma'am.
Thank
Thank
you,
you,
ma'am.
ma'am.
Thank you.
Thank you.
Thank you, ma'am.
Thanks.
Thanks.
Thank you, children.